Hello and welcome to Numeristical. We are continuing our series on baseball prediction. Now, if you've been following this series, you remember in our last video, we built our first model and actually came up with predicted probabilities on each game, and the predicted probabilities were better than the naive, better than really a simple naive benchmark, so that was good. But we didn't really know how to judge how good our predictions really were, and we said to do that, we really have to compare what we're doing to what the Vegas odds makers are doing and compare our probabilities. So in this video, we're going to do a few things. First, we're going to talk about how odds work, how betting works in baseball. And then we're going to show how to get some actual historical odds data for these games so that we can then compare what our model is predicting to what the Vegas bookmakers were predicting for the same games and see if our model is actually good enough to make money. So we're going to talk about how all that's done. Before we get started though, I'd really like to ask if you could like the video and subscribe. It would really help me out. So if you could take a moment right now to do that, that would be great. And with that said, let's get started. So how does betting on baseball work? Well, the standard bet in Las Vegas to make if you want to bet on a particular team is to make your bet with respect to a money line. So that line represents the probability that the odds makers have set that a team will win a particular game. So obviously if you're betting on a team that's very unlikely to win, you want to get paid a lot more if they do win. And conversely, if you are betting on a team that's a big favorite, you're only going to make a little bit of money when they win. So the less likely it is for a team to win, the more money you make on your bet if it does in fact win. So suppose that a team has a probability 1/3 of winning, and you're betting $100 on that team. A fair bet would pay you $200 if you win. And the way to think about that is for every 3 bets, you're going to win once and lose twice. So if you're going to net out to average in the long run, you need to win $200 for every win to make up for the double $100 loss you're going to pair with that. Now, in the US, these odds are represented by a line value. And the line value is either a positive number, bigger than 100, or a negative integer less than negative 100. Now these can be a little bit tricky to interpret, so let's walk through some examples. A positive number means the team is an underdog, and the implied probability that goes along with that line is given by the formula 100 over 100 plus the line. So for example, if the line for the Angels is plus 150 against the Dodgers, the implied probability is 100 over 100 plus 150, which is 100 over 250, which is 0.4 or 40%. So that means if Vegas is paying you at that rate, that means that the Angels need to win 40% of the time for you to break even on that bet if you made that bet over and over and over again. Now a negative number means the team is the favorite, and in that case, the implied probability is minus line over 100 minus line. Now it's a little confusing because line is a negative number. So another way to think about that is forget about the negative sign. It's going to be line over 100 minus line, and we're ignoring the negative sign. So if the line for the Cubs is minus 300 against the Dodgers, let's forget about the negative sign. You've got 300. The probability is going to be 300 over 100 plus 300. Or 300 over 400 is 75%. So it means the Cubs are a pretty big favorite in this example. And another way to think about that is when the line is a positive number, you're betting 100 to win 150 in the above example, when the line was plus 150. When the line is a negative number, that tells you how much you have to bet to win $100. So it's minus 300. That means I have to bet $300 to win $100. Because in this case, I'm going to win on average 3 times as much as I'm going to lose in the long run. So I've got to bet 3 times as much to win a single unit. Now, since bookies are trying to make money, they're going to slant these probabilities on both sides in their favor. So for example, if a game is truly 50-50 and you bet $100, you're typically not going to win $100 when you're right. You're only going to win $90 or $95. And this means that the implied probabilities on both sides of a game will add up to more than 1, more than 100%. So when a game is 50-50, Vegas is only going to pay you as if the true probability was, say, 52% or something like that. So this edge that Vegas is putting, and this is how they make money. If they didn't put an edge, they would not make any money. So they have to put this edge, and this is sometimes called vigorish or vig. But let's get started now with how are we going to get odds data for our models. So we've got all these historical games, and we want to know, what did Vegas think about this game before it started? What was the line on the game? And fortunately, there's a lot of odds data online. So we're going to go to one particular website called oddsshark. If you click on this link and you scroll down, you see they list all the teams here. And if we pick a particular team, let's pick the Chicago White Sox since they're listed first. You could then pick a season starting from 2019 up through 2022. And let's pick 2019, for example. And this gives us in a nice table every team the Chicago White Sox have played, who their opponent was, whether the game was regular season or in the playoffs. What the result was, of course, we didn't know that before the game. Then also gives us the line. So in this case, for example, against Kansas City, this is saying that the Chicago White Sox were a slight underdog. We also have these two numbers here, which are they say OU and total. So this is another bet that we'll talk about at some point, which is the over-under, which is you're betting on just how many runs were scored in total in the game. So in this case, Vegas was saying the over-under is 8.5, which means you could make a roughly even money bet. Again, it wouldn't quite be even money because of the vig, but you could make a roughly even money bet on whether you think there's going to be 9 or more runs total scored in the game versus 8 or less runs scored. But you can see this web page is pretty nice, and this table is really nicely formatted and gives us all the games for the season. So this is great. And if you see, we have a URL right here, and we could copy that URL. And let's go back to our notebook, and we could read in this URL. So I'm using the pandas read HTML function, which essentially reads the HTML on the page, but it nicely formats tables if it finds them. So this is a very useful function. One thing to notice is that I have this bracket 0 over here, which means kind of take the first element that you find. So we can run that, and you see that we get the table, and it's really nicely formatted here. So we get all the rows, the columns come up accurately, and so forth. So this is really, really convenient for us, right? So, and what's also nice is this URL seems to have this very nice format where you've got season equals, I could put a different season here. So let's type in 2020 and see if that works. So you can see now I've got all the games from 2020. The season started in July because of the pandemic. And we've got this number here, 27018. And if we play around this website, you know, we could think that probably represents the team. It's not clear how they got that number, but let's sort of test. If I press Cleveland over here, and I pick a season again, 2019, you'll see I get another number, 27024. So if I change 27024, now I'll get Cleveland's games. So all we have to do is figure out, okay, what's this number that corresponds to each team? And then go through the seasons. They have 2019 through 2022, so they've got 4 seasons per team. But that's good enough for us because we're really just going to use these odds to evaluate our model. We don't really need them for training. So we're going to use these odds to evaluate, and since we're building our model in the earlier years and testing on the later years, this should be sufficient. So let's look, again, we can look at this data frame. You see we have just these 7 columns. They all look nice. Now I came up with here this function line to prob, and this just implements the formula that I outlined earlier. So what's our plan of attack to get this odds data? Well, we want to get the number for each team. Remember, there seems to be this 5-digit number that represents each team. And then for each team and for each season, we're going to read in that table. We're going to do some processing of that data frame. So we're going to take out the playoff games because we really just care about the regular season. We're going to work with the date. We're going to add the game number. We're going to add what team we're talking about because it doesn't actually say which team we're talking about in the table. And we're going to convert the line value to a probability. And again, some of this you could do, if you wanted to, you could do this offline. You could just load in the raw data first and then reread it and do all your processing. But since this is a pretty simple bit of processing, I'm just going to do it as I load these things in. So this is a very light web scraping task. And you see, I saved you the trouble if you just went through this website and backed up and clicked every team and saw what number appeared here in the URL. You could get this dictionary. So I did it for you. You could see it goes from 26995. The Phillies were the first team for some reason, and the Cleveland was actually the last team. And so these are the code numbers. So I've done this so you don't have to do it. And now I'm going to write a little loop to grab this data. So what am I going to do? For I in this range, so I'm going to cover every single one of these numbers, and I have them in a dictionary now. So you give me the number, you could pop it into this dictionary and get out the 3-letter abbreviation that's used in our other data. So if you remember, we have this data frame of all these games that we built our previous model in. And what we really want to do is we want to add that odds information into that table so that for each game, we can know what was the line for each team involved in that game. So I'm going to get the team name with my dictionary for every team and for every season from 2019 to 2023. I'm going to generate the URL that I want. I'm going to read the table just like we did above. I'm going to drop the games that aren't regular season because I'm not going to use those for my model right now. Then I'm going to make some new columns. I'm going to say team source is my team name, so I just have in the data frame who the team is that they're talking about. We're going to have the season it is, because again, that's not in the data frame, so I'll just put the season in there. We'll have the date, so I'm going to format the date and make it just a number. I'm going to put in the game number, which tells me which game of the season it is. Now again, we have to be careful here. We're assuming that they're going to put the names in the appropriate order. So that's one thing to watch out for. And then we're going to calculate the probability, the implied probability of that team for that game. And then I did a little bit of sneaky formatting here. I was worried about double headers. So you might have 2 games on the same date, right? And then it might be hard to link up which game they're talking about. So I did a little bit of clever things where I said if the two dates are in a row, if you have the same date twice in a row, I'm going to assume the first game is the first game 1 of the doubleheader, and the second game is game 2 of the doubleheader. So that's all these lines do. And then I'm going to generate this doubleheader number, which is the same format as we used before, where it's going to be 0 if there wasn't a doubleheader for that date for those teams, and then a 1 or a 2 if it's the first or second game of the doubleheader. And then I'm going to just output this to a file. And I put this time.sleep here, so this is a common thing if you're going to scrape web pages. If you hit them too fast, they will often start blocking you. So it's good to put in a little bit of sleep time where you say, grab this web page, okay, wait a little bit, then grab the next page, wait a little bit. So I just put in 0.1 seconds, and for this case, that's sufficient. Okay, so we're running now, and you see it's going pretty quickly through these seasons. I might time warp here to get us to the end quickly. Okay, and we are now done. That just took a few minutes. And we've got all the teams here, and we've got all their odds data. And next, we're going to jump into our next notebook, where we're going to augment our previous data frame with this odds data. As a reminder, the link to all of these notebooks is in the description for this video. So if you want to follow along, please do, and please go to my GitHub page and get the notebooks there. So next, we're going to go into our second notebook, where we're going to load in our previous data frame and add in the odds data. Okay, so this is our next notebook, and here we're going to assume that you've run the previous notebook, so we've got those files with the CSV files that have the historical odds data, and we're going to load our previous data frame, the one we got from lessons 1 and 2, add in this odds data, and then do some more examination. So to get started, first we're going to read in this data frame that we had before, this dfbp1.csv. And what's our plan of attack? Well, we're going to create a dictionary structure that enables us to easily find a specific game for a team and a season. So and then we'll go through our main data frame, and we'll look up the home team and the visiting team, and we'll have to look up the home team in our odds data structure, get the odds for that particular game, and do the same for the visiting team. Because remember, the probabilities don't sum to 1, so you actually have to do 2 lookups. You have to look up the home team. What kind of bet could you make on the home team? What kind of bet could you make on the visiting team? So we're going to take the same dictionary we had before that just maps the team numbers, the team names that oddsshark used. We're just going to iterate through the teams. We're going to load in the data. We're going to load in the CSV for each team for each season. These are all the CSVs we created last time, right? One for each team for each season. We're going to create a new column that's date doubleheader. So we're going to take the date as numeric, the date numeric that we created before. We're going to take the doubleheader we're going to put together. That's going to be our indicator for a particular game. And so we know, hey, I want to find what were the odds for the Chicago White Sox on this date and doubleheader combination, and we want to be able to grab it. So to that end, I'm going to set the index for each of those data frames to be the date doublehead, so that it'll be really easy to grab out that row. So when you set the index in pandas and you want to look up a particular index, it's much faster than if you just try to do a search on another column. And then we're going to put this data frame in the dictionary. So we're going to be able to look up a team name and a season, and we'll get that data frame representing that team and that season, and then we'll be able to pick a game and look it up. So these lookups should be very fast, which is good, because in our second piece, we're going to then go through every row of the data frame and look up that particular game. So we need these lookups to be relatively fast. So you see, this was very quick to create. We loaded in all these data frames and made a dictionary structure out of them. And now, again, our approach is going to be to go through the main data frame, get for each row of the data frame, figure out who's playing, and then grab the odds for the home team, the odds for the visiting team. So we're going to initialize some rows to empty. So these are the new columns that we're going to add in. We're going to start with a few vectors as NumPy arrays. And then we're going to use df.iterrow. So we're going to go through each row. And if the season is before 2019, we're just going to skip through it, because we know that we only have the odds data for 2019 and later. So it's going to go really fast at first, because we're just going to quickly skip over everything before 2019. But then once we get into 2019, we're going to get the season, get the home team, get the visiting team. We're going to get these home and visitor games. We're actually not going to use these, but they're still in the code. Then we're going to get the date doublehead. So what date it was and whether it was part of a doubleheader or not, and if part of a doubleheader, which game it was. And then we're going to use a try except here because there are a couple places where it's not going to find the game. There are a couple places where oddsshark is missing a game or so forth. So we have to put things in this try and except strategy. So what this means is we're going to try to find the game. So we're going to, if I do take my odds dictionary, look up the home team, look up the season, and look up the game, and grab the implied probability that I calculated before. And then we're also going to grab the over-under and the over-under result. Now, if we get a key error, we don't want this thing to stop. We're just going to print a message that says we couldn't find this game with respect to this home team on this date, so that we can see if we want to try to correct it or not. And then similarly, we're going to do a lookup on the visiting team side. Look up for the visiting team what was their implied probability. And again, get a key error. If there's a key error, we're going to print that out. So let's let this run. So you see it's going super fast now because it's just going through the continue part of the loop. And now you see there's about just a few games where it didn't find. So Chicago versus Seattle, it couldn't find it. Atlanta versus San Diego, there are two different games that couldn't find it. You can see they're all on in 2021. So if we cared enough, we could go in and try to see what happened there, try to recover the odds, or we could just say, hey, it's 3 games. We don't really need to worry about it so much. And now that we've created these vectors, we're just going to add them to our data frame. And since we only have 3 games with no odds, I'm just going to drop them. So if the implied probability is 0, which is what I initialized it to, and the season's greater than or equal to 2019, I'm going to drop it. So first I'm going to look at them. So I have these 3 rows to make sure that this condition actually gives me the same game. So we see that these same games, June 26, 2021, between Chicago and Seattle, and then the 2 games on 2021, July 21st. Looks like there was a doubleheader that we didn't pick up. But that's fine. Since it's so few games, I'm just going to drop them. And then you can see that we dropped 3 games. And then, so we went from 96,276 games to 96,273. And then I'm just going to reset the index and save this data. So that's it. So that's all we have for this video. In the next video, we're now going to start analyzing these odds and understand how our model is doing with respect to the Las Vegas odds. We'll also do some analysis of how much, what else we can learn from the odds. For example, how much vigorish on average does Las Vegas take, and is it the same for every game? Is it different for different games, and so forth? So I hope you'll join me for that. In the meantime, again, if you could please like the video and subscribe to the channel, that would be really helpful to me. And I look forward to seeing you in our next video. Have a great day. Bye-bye.